This video will deal with different types of soil, discuss the difference between residual and transported soils, and give some examples of transported soils. We'll start with this diagram where we see current landscape on the Gold Coast. There used to be a volcano here, which was weathered over a billion of years, and all this material was transported to the beaches. However, some material was weathered, but it still remains where it was before. So this is what we call residual soil. This is something that stays where it was formed. Opposite to it are the material that was transported to different parts of the Gold Coast, either by rivers, rainfalls, or wind. So all this material is called transported soil. Transported soil is very common compared to residual soil. Unfortunately, we don't know much about the properties of residual soil because most of our infrastructure is built on transported soils. Human beings tend to build next to rivers on nice flat areas, not in the mountains. That's why we have plenty of data about transported soils, and this is something that we will discuss in this video. There are different types of transported soils, and they depend on the type of transportation. So the first one is glacial soils. This one is formed by transportation and deposition of a glacier. It's very common in North countries like Canada, Scandinavian countries, Russia. We don't find a lot of glacial soils in Australia. But this is actually a soil that has very good properties. It's very hard, it's well sorted, and it's nice to build on this type of foundation. Next type is alluvial soil. It's very common. So alluvial soil is formed by deposition of running water. Basically, it's formed by rivers. It's everywhere where we have rivers, and rivers are in all parts of Gold Coast, and not only Gold Coast, also in Australia. It's a very common type of soil. Unfortunately, it's very soft. There are many issues with this type of soil, and we will talk about it in this course. Lacustrine soils, they're as soft as alluvial soils. They are also saturated with lots of water, but compared to alluvial soils, they are formed by deposition in lakes. So they are not well spread in the country and around the world, but there are some local areas where we find lacustrine soils where there used to be lakes, and these deposits were accumulating in those lakes. Marine soils, it's very common. Marine soils formed by the deposition in the seas, and we have lots of marine soils around Brisbane, where we try to build our infrastructure. All East Coast, there is lots of marine soils there as well, and I will show you a few examples later. Aeolian soils, that's a very interesting type of deposition. So it's deposited by wind. We have lots of aeolian soils in the western part of Australia. It has very interesting properties. Aeolian soils are hard when they are dry, but if you add just a little bit of water, they just collapse. So this is something that we need to keep in mind when we deal with this type of soil. And the last type of soil on this slide is colluvial soils. So everything formed by movement of soil because of the gravity. We have lots of colluvial soils on slopes, along major routes and roads. This is an example of alluvial soil from New Zealand. You see all this area around the river is all alluvial soil. You see that because it's next to the river, this type of soil should be very soft with lots of water in it. It should be also loose, and it's very dangerous to build on this type of soil because it doesn't have much of bearing capacity. Whatever you build on this type of soil may settle or even collapse. So we need to be very carefully, and we need to think how to deal with that soil, and this is what we'll discuss in this course later. This is just an example of colluvial soil. Everything that we have here on the slopes, either it moves or it still sits there. All this, it's colluvial soil. Of course, nobody will build anything on this type of soil because it's unstable, it's loose, and it's just very weak. Marine soil, as you can see here, it's something like this mud from Port of Brisbane. Definitely this is very weak, very wet. It has basically zero bearing capacity. Whatever you build on this soil will just settle or sink in the soil and collapse. Again, we need to deal with this soil, for example, for Port of Brisbane. Port of Brisbane tries to reclaim this area around here. You will see that actually they bring sand here and build settlements. But when you bring sand and build these embankments, you place them on very soft material like it's here on the ground. And this material is very soft. If you try to place any embankment, this embankment will collapse. So we need to know how to deal with these soft marine soils. Aeolian soils, as I mentioned before, it's a good foundation when it's dry, but unfortunately when you add a little bit of water, this soil will collapse. Aeolian soil has very interesting structure when it has lots of pore space in between particles. It's strong when it's dry, but when water goes in the soil, it will resolve those bondings between the particles and make the structure very soft and very weak. That's why we have collapses here. Like I'll show you a few examples. It's all here.